So this is topic 4. This will be the first recorded lecture for the spring of 2022 on carbohydrates. And so let's get into this. So first, what's the deal about carbohydrates? They are actually great nutrients. In fact, they are essential for our body. One of the main things to say about carbohydrates is that they are essential for your energy needs. In fact, your brain, the only molecule your brain can use for energy is glucose, and glucose is a carbohydrate. Because I just mentioned the brain and the nervous system. Carbohydrates are good for your digestive system. They can keep the body lean. There are indigestible carbohydrates such as fibers that don't have any energy, but they provide many other benefits, and we're going to talk a lot about fibers today. In fact, if you look at what the DRI committee recommends, they recommend that most of your diet, so 40 to 60% kind of is the range of your calories actually come from carbohydrates. And this recommendation is dealing with complex carbohydrates, not refined sugars. And we'll define what that means here in a few minutes. So what do carbohydrates do in the body? Energy, that's obvious one. We just talked about that. Many carbohydrates are structural in your body. So there's things called glycoproteins and glycolipids that are part of your membranes. If you're familiar with the A, B, O blood groups, those are carbohydrates. There are carbohydrates found in your joints, proteoglycans and things like that. They're part of absorbing shock in your joints and all sorts of reasons why we have carbohydrates in the body. Carbohydrates are also used as building blocks to other compounds. So sometimes our body will synthesize amino acids and use carbohydrates as a building block to build those amino acids and so on. And much more. But the big one, of course, is an energy source, and carbohydrates are essential for that. If you take a look, this is kind of an expansion of carbohydrates. You can see it's expanding to not just talk about carbohydrates in the body, but also what carbohydrates do in food. They taste good. They can add texture and browning. Certain types of fibers can add gelling factors and those kind of things. And so, of course, carbohydrates are essential for those kind of things as well, the eating experience, of course. So let's talk about what is a carbohydrate. From a chemical structure, so by the way, my background is biochemistry as well, and so I do like chemical structures. If you don't like chemical structures, that's okay. I probably won't be asking you much about chemical structures, but I will be throwing them up on the slides from time to time, and try not to be afraid of them. Carbohydrates basically have carbon and hydrogen and oxygen. So this is similar to fats, but there's a lot more oxygen in carbohydrates. In fact, one of the things that carbohydrates have a lot of is usually these OH groups. That's oxygen, hydrogen. These groups are called alcohol groups. So you're going to see these alcohol groups in all the carbohydrate structures that I show you. The simplest type of carbohydrates are called monosaccharides. So mono means one, saccharide means sugar, and there's a whole bunch of them out there. The most common ones are shown here on the screens of glucose, fructose, and galactose. So I'll come back and talk about those here in a moment. So here's just a little bit more chemistry for you. So by the way, carbohydrates can be called sugars or saccharides or polysaccharides, and the terms are used somewhat interchangeably, although sugars are usually referring to simple carbohydrates. And that's the way I'm going to use them in this course, is referring to simple carbohydrates. There's a structure for sucrose, that's table sugar. You can see it has some alcohol groups, and a lot of carbohydrates often also have these ester groups or sometimes carbonyl groups. But again, I'm not going to worry too much about the chemistry. I just like chemistry. So where do carbohydrates come from? Ultimately, you can kind of think of carbohydrates as being produced by photosynthesis. So plants, of course, are the organisms that do photosynthesis. And the energy of the sun is used to capture carbon dioxide and make it into organic compounds. And one of the most common products of photosynthesis is glucose, and then glucose becomes the basis of forming almost all other biological molecules on the planet. So most carbohydrates in our diet are coming from plants. The only real exception is milk. Milk is really the only animal product that has a lot of carbohydrate in it. So it's kind of an exception. And we'll talk about milk a little bit later. Milk has a carbohydrate called lactose in it. And we'll talk about the consequences of eating lactose for some of us. So let's get into and talk a little bit about dietary carbohydrates. And often they're thrown into two categories. Complex carbohydrates, these are the ones that we want in our diet. This involves both starch and fiber. And these are basically essential nutrients. Simple carbohydrates are sugars, so they're smaller ones. They tend to be very easily digestible. And in many cases, they're, as you can see on the slide, it says they're replacing nutrient-dense foods. And so, we're trying to cut down on the simple carbohydrates and eat more complex carbohydrates. That being said, if you're working out, complex carbohydrates may not be the best option. They are slower to digest. They give you a full feeling. These are not necessarily the type of things you want to do if you're going to compete in a sports event or have a game or a workout. You want quicker energy, and that's where simple carbohydrates do come in. Complex carbohydrates can give you that full feeling. They can reduce cholesterols, and they usually provide a lot of other vitamins and minerals. Vitamin B is pretty common in the vitamin Bs. There's a whole bunch of them are very common in fruits and vegetables and grains. And so a good source of them is by eating other complex carbohydrates. So let's just take a look here at some nutrition facts labels. If you take a look here, I have Weetabix, and I compare that with some Smarties. So, let's take a little look at this here. If you look on the left here, I'm just focusing in on the carbohydrates part of the nutrition facts. And what I was trying to do is find things that were kind of similar in terms of the serving size. So 35 grams in the cereal versus 40 grams in the Smarties. And so you can see that we're looking at about 29 grams of carbohydrates, 31 on the Smarties. So very similar in comparison. But if you take a look, the profile is very different. Weetabix is a source of fiber, 4 grams per 35 grams. It's not a massive amount, but it's pretty good compared to a lot of cereals. And I'll show you another cereal here in a moment. 23 grams of complex carbohydrates. I guess it depends on how you do the math, but 23 grams, how did I come up with that? I took 29 grams and I subtracted the fiber and I subtracted the sugars. So what did we have for fiber? We had 4 grams. And for sugars, we had 2 grams. So that's basically 29 minus 6, which is 23 grams. Sometimes people will actually consider fiber part of the complex carbohydrates. For me, it's either. It doesn't really matter. So sorry if there's any confusion there. So generally, the complex carbohydrates, they're going to be absorbed and be digested more slowly. So you're looking at sustained energy over the day when you eat something like Weetabix. And like I said, the fiber is great. It's good to have. And generally, things with complex carbohydrates often have a lot of other nutrients in them as well, depending on the food. In this case, you can see a pretty decent source of iron and thiamine. If you take a look at the Smarties, on the other hand, so similar amount of carbohydrates. And what you're looking at is mostly sugars. So 29 of the 31 grams of carbohydrates is sugar, no source of fiber. And it has its place. It'll give you a short burst of energy. Not a bad idea to eat something like this right before, right after working out. Gives you energy to work out, and maybe afterwards gives you a chance to settle and re-establish some of your muscle glycogen. But don't fool yourself. You're not getting a lot of other nutrients out of something like that. So complex carbohydrates, that's where we want to focus, and also getting lots of fiber and a lot of other nutrients will come along with them. Here's a comparison of another cereal, by the way. I was looking to see what I had in my cupboard. Somebody at home likes Lucky Charms. I can't really handle them myself. They're too sweet, but wanted to see how they compared with Weetabix. And so the serving sizes aren't quite identical, but kind of in the same ballpark. And if you take a look over here, you're looking at half the amount of fiber and way more simple sugars. So if you look at what are you getting out of this in terms of complex carbohydrates, in terms of the starches, so 23 minus 2 minus 9 grams, so that's 23 minus 11, which is, of course, about 12 grams of complex carbohydrates, right? So complex carbohydrates. So, it is a source of energy and starch, but overall, maybe a little bit less nutritional and, not a bad breakfast, but if you really want to go a lot better, go with a Weetabix. So here's something else just to point out too, right, in terms of these food products and why it's always worth it to take a look at your nutritional labels. Vitamin water, it seems to be a pretty popular product, and I've had some myself. I don't really care for the taste of some of the flavors, but I was kind of shocked to look at this whole thing and realize that they're loaded with sugar. I did not realize they were loaded with sugar until I looked at the nutritional labels. And if you take a look at the options here, vitamin water versus actual water and some fresh fruit, you're getting a much better deal. In the fresh fruit, you're also going to be getting fiber along with vitamins. So, another reason to choose water as your drink of choice and supplement that with some actual fresh foods. So let's take a closer look at these simple carbohydrates that we're going to call sugars. These are the three main ones. Glucose is maybe the most abundant biological molecule on the planet. And it's the main product of photosynthesis. It's one of the main sugars that's found in fruits. And it's also part of table sugar. I'll talk about table sugar in a moment. That's a disaccharide. Fructose, also very common, not quite as common as glucose, but kind of gets up there. It's a predominant type of sugar you'd find in honey and many sweet things. Sucrose or fructose is actually quite a bit sweeter than glucose. So anything that's really sweet is often high in fructose. So like strawberries, for example, have a lot of fructose in them. Galactose, you're going to find that in your milk sugar. It's actually part of lactose. And I'll talk about that here in a moment. But these things are, for the most part, relatively interchangeable in terms of the way the body deals with them. Maybe fructose a little different, and we'll talk about that here in a moment. If you take these sugars, these simple sugars, and you combine them and put two together, you can get disaccharides. So di, of course, is two. And so we have lactose and sucrose and maltose. You can see they come from different sources. Lactose comes from milk. You can see it's made of galactose plus glucose. Sucrose, this is your table sugar. This is the most common type of sugar most of us are consuming because it's added to quite a number of products, but also found in quite a number of fruits and other natural sources as well as part of the natural sugars that are found in those products. Maltose is a little bit more common in grains. And it's also actually a breakdown product of when we eat a lot of starches. Our body actually breaks them down into maltose before breaking it down into further into glucoses. So lots of sugars out there, and all these simple sugars are the ones we're trying to cut down in our diet because most of us eat too much of them. If you take a look, there's all sorts of studies done. I was looking for a Canadian one, but this is kind of one of the had some nice graphs on it. This is Americans. Canadians are very similar in their dietary habits as Americans. And it's basically showing the sugars in the diet, and they've gone up, particularly since about the 1980s. And one of the consequences of this is roughly around the 1980s, 1990s, fat was being vilified. And so what a lot of people did was they started to buy low-fat products and cut down on fats, but their increase in sugar consumption went up quite a bit, which of course is not good. If you're going to take fat out of your diet, you probably shouldn't be substituting sugar, unfortunately. One sugar I want to talk about just for a minute or two is this high fructose corn syrup. And this is really common in a lot of products. And there's good reason for this. And in Canada, by the way, often it's called glucose/fructose. So if you see that on your juice box or some other product, it's basically high fructose corn syrup. So what is going on here? If you take a look at sucrose, so this is table sugar that you might have, and it gets broken down into glucose and fructose, right? High fructose corn syrup is basically where we take glucose that's in corn syrup, and an enzyme is used to treat it, and it turns into glucose and fructose. There's different formulations. Sometimes you get 45%, 55% and whatnot. And usually what they're trying to do is promote fructose formation because fructose is really sweet. And this makes things taste good. And of course, corn syrup is cheap. And so this is a cheap way to make your products sweet. And so this stuff is found in all sorts of products. I have a little video on this I'll play for you, and then maybe I'll say a few more things about it. So let me just play this video for you right now.
So what's the difference between high fructose corn syrup and sugar? Even though it seems like high fructose corn syrup is in every single food and drink wrapped in plastic, you can't find it for sale alone on the shelf. And since there's a little bit of mystery about this stuff, let's take a look at how different these two sweets are and settle this once and for all. High fructose corn syrup made its big-time market debut in the 1970s due to new taxes on import sugars as well as subsidies on corn crops, making it a much cheaper sweetener than regular table sugar. Since then, it's become a pretty standard part of the American diet. High fructose corn syrup doesn't come about naturally, but instead through a pretty advanced chemical process. Corn is milled down to produce cornstarch, which is then further broken down into corn syrup, a product that is almost entirely made up of a sugar called glucose. And while glucose is sweet, it isn't sweet enough to do the job. So in the lab, certain enzymes and acids are used to convert some of the glucose into fructose, which is significantly sweeter. So high fructose corn syrup is a mixture of these two compounds that comes in different variations. Glucose and fructose are what are known as monosaccharides, the simplest kinds of sugars, and also the building blocks of the more complex disaccharides. Now, what's important to realize is that common table sugar, or sucrose, is a disaccharide made up of equal parts of glucose and fructose. High fructose corn syrup comes in different concentrations for different products, but it's remarkably similar. The current scientific consensus is that there's almost no nutritional difference between the two. So when it comes to discussing health issues with sweets, it's much less about this than it is about this. When you eat either table sugar or high fructose corn syrup, both inevitably send glucose and fructose into the bloodstream. Glucose charges our cells up with energy, while fructose gets involved with cholesterol and energy-storing glycogen production in the liver. One of the big problems with overconsumption of sweets is that they start interfering with our metabolism and even start playing games with our brain, confusing our sense of hunger and even our feeling of being full. The more sweets we eat, the more possible physical damage they can do to our bodies. Large amounts of fructose, for example, can do a number on your liver and has been directly linked to obesity, heart disease, and diabetes. The American Heart Association suggests that women limit themselves to 6 teaspoons of added sugar per day, while men limit themselves to 9. That's pretty drastic considering the average American consumes around 23 teaspoons a day. So the big takeaway from all of this is to put a cap on your sweets. It'll do you good in the long run. Now, on the topic of sweets, check out this video about the chemistry of artificial sweeteners and this one on ice cream. Thanks for watching. Don't forget to subscribe, and we'll see you again soon.
Okay, so let me just go back to the previous slide for a second here. He touched on some really good points there. I just want to comment on a little bit more around this whole thing. Part of it is just our consumption amount of these things. So sucrose and high fructose corn syrup, part of the problem is that over the years, this high fructose corn syrup has been added into more and more and more products. So it means that people's consumption of sugar is up quite a bit. The other problem might have something to do with the fructose a little bit here. It turns out that our body is really good at breaking down glucose. Fructose, on the other hand, is only really absorbed and broken down by the liver. And if you have a lot of this in your blood, let's say you drink a soda or a juice box or something like that, or you have 3 juice boxes, now you have a lot of fructose in your blood, and the liver can only work so fast. And so what it does is it says, okay, I've got a lot of fructose here, and then it will turn it into triglycerides, which is basically fat. So there's a lot of studies that show people who have a lot of high fructose corn syrup in the diet do start to get fatty livers and things like that, which is certainly not a good thing to have. And we'll talk about fatty livers a bit more when we talk about alcohol consumption. Like I said, it's used because it's cheap and it's sweet. And another thing that he hinted on is that sometimes, fructose doesn't interact with your hunger hormones the same way glucose does. And so people can end up with basically with too much fructose in the diet, your blood sugar spikes, but you don't feel full. And so people continue to eat. And of course, this can lead to, obesity and things like that for people who have habits of drinking lots of high fructose corn syrup drinks and those kind of things. Overall, fructose is not a bad thing, found in many fruits and whatnot. Again, it's just all about the moderation and whatnot. And when consumed with, in fruits where you're getting fiber and other beneficial nutrients, you're looking at a lot of other benefits from it. Again, it's the high amount that we're most concerned about. There's the video again, and I think I actually have a second.
So what's the difference between
Sorry about that. I actually have a second video if you're interested in a bit more depth in this whole thing in terms of what's going on physiologically. You can take a look at this one in your own time. So let's talk about polysaccharides. And so here's our glucose. And so glucose can be formed together in these long chains. And these long chains are something we call starch. And this is actually what we have in food. And this is what we're thinking of when we think about complex carbohydrates, or at least consuming complex carbohydrates. Animals kind of do a similar thing. They make something that kind of looks a little bit like starch. It's called glycogen. And this is the way that we store glucose in our bodies. We store this in our muscles and our liver. You can see, like I said, a very similar starch. It's a little bit more branched, which makes it a little bit easier for animals to access the energy more quickly. The other type of polysaccharide or complex carbohydrate to be concerned about is something called cellulose. And in dietary circles, we call this fiber. This is part of the plant's cell wall, and this is basically completely indigestible by humans. And so that's actually a good thing, because there's a lot of benefits of having fiber in your digestive tract, and we'll talk about that here shortly. So let's talk a little bit about starch and glycogen. If you take a look again, here's just some other pictures from a different textbook of starch, and they're showing these starch granules stored in the food. Starchy part of plants can be things like the grains, or a lot of root crops such as carrots and potatoes and beets, and those kind of things are a really high percentage of those foods are starch. And this is an excellent energy source for humans and omnivores and other animals in general. There's your glycogen, again, just different diagrams showing some of the same things, a little more branched. And like I said, this is stored in your muscles and your liver. So a little bit more on carbohydrate digestion and all that later. Here's our fiber, and there's a nice diagram showing the fiber, and it's a bunch of glucose molecules, but they're linked differently. The chemical linkages are differently, and they're hard for our enzymes. In fact, impossible for animal enzymes to break down these things. Fiber in general, there are lots of animals that eat high fiber diets, cows and horses. A lot of animals, that's pretty much all they eat. They eat grass and hay, which is almost completely made out of fiber, and they can't digest it either. But what you may not know is that they can break it down with the help of different types of symbiotic organisms. So we're talking about bacteria in general. Cows in general have a hard time digesting their food. You probably know they chew their cud, they chew constantly, they have multiple stomachs, these animals, because the fiber is very, very hard to break down. So you can think about fibers in a sense of really kind of two groups. And sometimes you hear about this in the food industry. They talk about soluble fibers and insoluble fibers. Soluble fibers are, they dissolve in water, at least to a certain degree. And these are famous for forming gels. They can be thickening or viscous forming agents in foods. They can be digested by some bacteria in the human colon. And so sometimes these soluble fibers do contribute to our diet. These soluble fibers are associated with a lower risk of different types of chronic diseases, and with the foods, they're often associated with good consistencies as well. You're looking at, these things are found in barley and legumes, fruit, oats, vegetables, those kind of things. There's an unfortunate side effect of these bacteria breaking down some of these soluble fibers. Sometimes that leads to intestinal gas, but we'll talk about intestinal gas here in a moment or two. Insoluble fibers, these are almost completely indigestible. They don't dissolve in water. You're looking at things found in the outer layers of whole grains, celery strings, foods like that. You can see there's some other samples there, right, of insoluble fibers. And these things tend to not be gellifying, but they do aid the digestive system. And they ease elimination of a lot of other foods and whatnot. So slightly different. Sometimes, like I said, you hear about this in the food industry, talking about soluble and insoluble fibers. Here's another video for you that it talks about sugar consumption trends and recommendations. I'm not going to play this for you as part of this video. You can please review it in your own time. It is certainly worth to take a look at. Let's talk about recommendations around consuming foods, and I'll get back to those fibers here in a minute. There's different recommendations on fiber consumption based on your activity level, and the World Health Organization has slightly different recommendations compared to Health Canada and the DRI. But this is what you're looking at, right? Basically, the majority of your diet, I think I showed you before, was it 40 to 60 or 45 to 65% of your diet should be carbohydrates. And there is a minimum. You do need some carbohydrates in your diet, or you are going to suffer health consequences because your brain requires carbohydrates. We can live without carbohydrates. We can convert proteins to glucose. It's not necessarily the best thing for you to do. So 140 grams is the recommended minimum per day by the health authorities. Another thing around carbohydrates is recommendations around added or free sugars. So you can see the World Health Organization and Heart and Stroke is recommending that you don't exceed 10% of your total calories. Heart and Stroke is actually trying to get people down to 5% or less. There's a lot that could be said about sugars. And one of the big effects is that sugar consumption can actually alter your blood lipids. Because that's what our body does. It converts excess carbohydrates into lipids, and that leads to risks around cardiovascular disease. So something we're gonna certainly talk about a little bit more later on this semester. One misconception about carbohydrates is a lot of people seem to think carbohydrates are going to make them fat. You know, if you eat too many of anything, it certainly is going to make you fat. But if you take a look at this infographic here, kind of saying, you know, take a look at these carbohydrates. It kind of depends on what you are consuming with your carbohydrates, right? The ones on the right are often saturated in fat, and there's lots of added sugars and things like that. Those things are high calories, and eating large amounts of those are going to certainly contribute to your weight. But lots of carbohydrates are great for us and are not going to make us fat. And there's all sorts of studies showing that if you take certain things out of your diet, so here's a very classical study done way back in the 1970s where they replaced people's diets. They had high protein, high fat diets and replaced them with rice and other fruit and things like that, carbohydrate diet. And these people lost a whole bunch of weight. So calorie consumption, right? If you consume more calories than you burn, you're going to gain weight. If you consume less calories than you burn, you're going to lose weight. It doesn't matter where you get them from. A calorie is a calorie in a sense. And we'll certainly talk about weight loss and body size at some point later on this semester. Here's another infographic here, right? Just showing that, you know, here's a slice of bread, only has 95 calories, but look at what this person has put on it, 30 grams of jam and 40 grams of peanut butter, next to 300 calories. So again, it's not just the carbohydrates are not the villain, it's everything else that you're contributing to it. So let's talk a little bit about fiber. A bit more about fiber. I want to kind of get into some specifics on fiber in terms of your health. World Health Organization is recommending 29 grams per day. I think, trying to remember what I saw for Health Canada, but you can see that they're recommending that, you know, 48 grams, 40 grams. I think I was reading somewhere recently that most Canadians get about 15 grams of fiber per day. So not enough. So most of us do need to get more of it in our diet. So you're probably wondering why you want more carbohydrates in your diet. So this is what we want to talk about here, right? And I'm just going to skip ahead a slide here. I feel like, okay, yeah. getting ahead of myself on this kind of thing. But here's the question, right? It says here, first of all, fibers actually promote normal blood cholesterol levels. How do they do this, right? So that's kind of the question I was going to write some notes on. So here's my question. How do fibers reduce cholesterol? Question mark. So number one, what is going on here, right? So blood cholesterol is used to make bile. So what is the big deal about that? So you may remember in the last unit, the whole thing about bile. Bile is made in the liver and is stored in the gallbladder. And ultimately what bile does is bile helps the digestion of fatty acids in the intestine. So maybe I'll just put a note about that. So helps digest fatty acids. Okay, so that's part of the picture here is we have bile. And so you have your meal and unfortunately when you consume excess fatty acids, these can be converted into blood cholesterol. That's kind of the problem. So here is the thing about fiber is that fiber actually absorbs bile. So it absorbs bile and it absorbs dietary cholesterol. And then what happens to that fiber? The fiber is excreted in the feces. So you may remember, again, just going back to bile, what bile does is it helps to solubilize fatty acids. And so along with the bile that gets excreted in the feces is, of course, extra fats. And that's kind of what we think is going on here. I've got a little graphic here from the textbook. And you can see they're showing on the left here is the high fiber diet. It says here that the liver uses the blood cholesterol to make bile. And you can see kind of what the whole key thing about the fiber is that the fiber basically absorbs excess bile, and the excess bile will include cholesterol and fatty acids. On the right, you've got the low fiber diet and of course little bile excreted, so excess blood cholesterol here. You can take a look at that, but really not much more complicated than what I said on the previous slide. What else can we say about fiber-rich foods? So promotion of normal blood cholesterol concentrations. And so what is the big deal about that? Of course, that makes a reduced risk of heart disease. Reduced risk of heart disease. Fiber can actually help to modulate blood glucose concentrations. So kind of the same way, what happens is when we have fiber in our diet, it actually slows down digestion of other foods. So if you have, like I said, if you eat strawberries that have lots of natural sugars in them, the fibers slow down the digestion. And so your blood glucose doesn't just spike immediately. Whereas if you just eat candy that has lots of fructose and glucose in it, your blood glucose is going to spike very, very quickly. So this would be leads to basically reduced risk of diabetes. Fiber also helps with kind of your bowel functions. It helps move things along the way, not get clumpy and hard as rock, and keeps things soft. And of course, that is a good thing as well. And so this leads to reduced risk of bowel disease and also bowel cancers. And as a consequence, high fiber foods give you a feeling of fullness. So they can help in the maintenance of healthy body weight. And I guess I mentioned the colon cancers here on number 3. Again, fiber, you're just going to hear about fiber. If you keep reading about nutrition, you're going to hear about fiber all your life. Fibers, like I said, it helps to soften up the stool, and that prevents all sorts of other things. this I'm not sure how to say this, diverticulas. And these are kind of like, I guess they're little pockets in the intestine that can trap food and lead to painful inflammation and things like that. Fiber-rich foods can lead to less risk of getting hemorrhoids. And hemorrhoids are something that a lot of us are going to get. I think it's something like 75% of people get hemorrhoids. So if you can try to prevent them or delay them in your life, it's a good thing to do. Lots of infographics like this on the internet talking about weight loss, protects skin health. I don't know how that is supposed to work, but mostly we're looking at digestive things such as constipation and cholesterol levels and whatnot. And you can certainly click on this link and go check out what they have to say about skin health. I've never seen that one before. A little bit more about fibers. I'm just going to skip this slide. You can read about it in the textbook. Here's a list of some high fiber foods that are out there. So oat brands and avocados, and anytime you're eating fruits and vegetables and you're leaving the skin on, the skin is often where the fiber is found. So you're more likely to get fiber if you eat the fruit as opposed to drink the fruit juice. Don't fool yourself about fruit juices. They don't have a lot of fiber in them. Maybe orange juice with the pulp in is better for you than the pulp out. I don't know about that, but probably because the pulp is basically indigestible fibers. Here's a few other foods on there. You can see this whole list. Again, you're looking at whole grains and fruits and vegetables, and a lot of legumes, including beans and peas and lentils, tend to have a lot of high amount of fibers in them, which is another reason why to eat more of them. So one thing we'll talk about kind of here and there is the Mediterranean diet. Mediterranean diet is, really refers to people that are living in certain areas around the Mediterranean. So Greece and Italy and Turkey and a few places like that. And a lot of these people tend to be really very, very healthy. And if you take a look at the food pyramid from the Mediterranean diet, is that a lot of their diet is consisting of fruits and vegetables and grains, smaller amounts, fish and things like that. And so a lot of people talk about the Mediterranean diet as being kind of an ideal human diet to strive towards. And one thing is that these diets have a lot of fiber. And of course, this contributes to a lot less risk of certain chronic diseases. So a little bit more on the Mediterranean diet later on. So one thing you may know or not know a lot about is, if you're trying to get more fiber, particularly as you get older, our digestive system just has a harder time pushing things through, right? I don't know whether that's because things get tired or whatnot. So there's a lot of products out there to help people get more fiber. And it's always better to eat the whole foods, but a lot of people supplement the fiber in their diet by eating all sorts of these products. So you can see these bran flakes and all brands, and there's oat bran bars and all sorts of other things out there. You can see gummies. I haven't seen those too many times on the shelf, but they're out there. Another one is this Metamucil. Metamucil is kind of like a powder you'd add to water, makes a drink, and it can be consumed and can help people with their regularity and those kind of things. So always good to have more fiber in your diet. So if you're concerned, look up some of these products. Okay, what else was I going to say about fiber here? There's some recommendations there. So I'm guessing all of you are probably between ages 19 and 50. You can see the fiber recommendation for men is quite a bit higher, about 48 grams per day, and women about 25 grams per day. One quick note about fiber is you can get too much of it. You can see right here, there are cases of some people a little overdoing it, eating entire boxes of oat bran bars and getting basically intestinal blockage. See, what's happening with fiber is absorbing a lot of water, and if you don't chew it well and things like that, it can absorb water and turn into blocked intestines. And of course, that's not what we want. Usually that doesn't happen. Most people are not getting enough fiber in their diet, but it has happened. One thing about fiber is it may absorb certain nutrients. I remember reading about this a long time ago. and talking about concerns about high fiber diets, maybe not helping people to get enough iron because fiber can apparently absorb iron as well. So, something to think about. But normally, like I said, most people are not getting enough fiber, and that's not the concern. Here's some infographics from the textbook, just showing differences between the red here is whole grain, the green is enriched, and the orange is the white bread. And you can see that the white bread is really just losing out on all the categories. It has less iron, less thiamine, less riboflavin, and so on. And of course, fiber being the big one. There are enriched breads that sometimes have added fiber added into them and those kind of things. So when you're choosing your breads, certainly it's worth it to find something that you like, but white bread is often not really that nutritious for us, unfortunately, even though if it tastes absolutely delicious. Here's just some comparisons of different types of flour. I won't dwell on that too much, but you can see that the whole grain flour is much better than the enriched white flour. Some nutrition labels between three types of breads. So again, you've got we've got this whole grain on the left with 2 grams of fiber, this natural wheat bread with 1 gram, and then what is this multi-fiber on the right? Has 3 grams apparently. So anyway, like I said, it's worth it to look at these nutrition fact labels. So what I want to talk about now a little bit is just your digestion of carbohydrates in the body. And I'll make a few notes around this. So one of the biggest sources of carbohydrates that most of us have in our diets is, of course, starch. So I'm going to write some notes on starch and talk about how that is digested. And you can actually see some of this in the diagram here on the right in terms of what is going on here. So starch, of course, is these basically chains of glucose. And so if you start over at the mouth, what is going on at the mouth? So that's the first place to start. So in the mouth, we have an enzyme called salivary amylase, and I believe I talked about it in the previous unit. So salivary, of course, means it's part of your saliva, and amylase means it's a type of enzyme that, believe it or not, breaks down starch. So what does this do? It breaks down the starch and splits it into maltose. So splits starch into maltose. Apologize if I'm writing really small. I'm just trying to squeeze everything I want to put in there. So remember, maltose is basically a disaccharide. So it's 2 glucose molecules attached together. So this digestion starts right away in the mouth. And then things go to the stomach. And the stomach, of course, has lots of acid in it. And these enzymes that are found in your saliva are deactivated by acid. So if you don't chew your food, you're already slowing your digestion down, particularly digestion of carbohydrates. Enzymes deactivated by enzymes. Okay, yeah. Deactivated by acid. Sorry. Sometimes talking and writing and thinking all at the same time, that's a lot of multitasking to do. Okay, so the intestine, of course, is the major site of digestion of all our foods and absorption. So in the intestine, we have many enzymes. So that's one thing to say. Some of them are amylases, so we're still breaking down the starch into maltose. And basically, these enzymes are breaking everything down, and they're going to break things down into smaller saccharides, so mostly disaccharides. Another type we might talk about is oligosaccharides, which basically means a few, so tri and 5 together and all that kind of thing. But ultimately, they get broken down into disaccharides in many cases, and then eventually these things get broken down into monosaccharides. And of which glucose is the #1 monosaccharide that's going to be in our diet, partly because that is the main component of starch. And then in the intestine absorbs these things. So we'll say this: the monosaccharides are absorbed. So then what happens? They go into the blood. And so if you take a look at the image there on the right, you can see the stomach and the intestines, and over here in this little box, you can see that the monosaccharides are going into the blood, and eventually they will pass through the liver. And so the liver is kind of one of the last places where things are modified. So once, by the way, once glucose gets in the blood, it can be used by all of your tissues, your brain, your muscles, and all those kind of things. The liver, though, is where it takes a look and it will absorb other monosaccharides. So, for example, it will convert galactose into glucose. So I'll put that one down. So converts galactose into glucose, and also fructose into glucose. And like I said, this is where when we get too much of these things in our diet, it will also convert the surplus, it will convert into fats. So this is where you eat too much, you eat too many donuts, and this is the consequent. Fats, our body will happily store fats. It says, hey, not a problem, I have a place for that. It will stick it all over your body. So that's starch digestion. So that's kind of point number one. I was hoping to have a little bit more room on this slide for a couple of other notes, but I think I have room on the next slide for a couple of other notes. And the other notes are shorter. Of course, we don't just eat starch, we also eat sugars. So sugar digestion. So the sugar, of course, is they're already simple carbohydrates, right? And so if they're they can be absorbed directly by the blood, by the intestine. So absorbed directly by intestine. Or of course, we have monosaccharide or disaccharides that we may have in our diet. So for example, we eat table sugar, right? So disaccharides are broken into monosaccharides. And that can be done by your salivary amylase, or it can be done by enzymes that are found in the intestine. And the last type of sugar, of course, are the fibers. All right, and so what about the fibers? We've already talked about these as being mostly undigested. So they're going to do all of the good things that fibers do, help soften your stool and those kind of things, absorb cholesterol and whatnot. Some are fermented by bacteria. So some fermented by bacteria, and we might digest some out of them, some carbohydrates out of them, bacteria. And unfortunately, some of these may produce gas, intestinal gas. And that's something we don't like, unfortunately, but it is part of being human. So let's talk about that gas for a minute or two here. Everybody produces it. That's a fact. And believe it or not, there's been a number of studies done on intestinal gas. And, you know, some people certainly do produce a little bit more than others, but most of us produce a pretty consistent amount. It's just the expulsion, of course, is where it may become problematic when and where and how you do it. But in terms of some tips, right? Chewing is helpful. Some intestinal gas is just food that's or gas that's trapped in people's food from not chewing enough, unfortunately. Some of us have different profiles of bacteria and may make more gas or less gas than others. And so you can see some of the tips here about having small serving sizes. And some people do have problems, and there are commercial enzymes and prescriptions that can be found for these kind of things. But a big thing, right, some people say is, you know, certain fiber-rich foods affect different people differently. And I think on my next slide, I have some comments on that. I had it somewhere about, you know, probably you might know that beans are famous for, you know, causing some people to have gas. And for some people, it's actually milk as well. So usually the recommendation is if you have issues, try changing your diet a little bit, you know, maybe take one thing out of your diet and keep eliminating that one thing or eating less of it until you have less problems about it. like any medical issue, if you have extreme problems, go see a doctor, please. I want to kind of wrap things up here for this lecture, this first part, and talk a little bit about milk digestion. So you probably know that some people cannot digest milk. So everybody can digest milk when you were a baby. That's part of being human. Babies drink milk, breast milk, or formula when they're quite young, and produce an enzyme called lactase. So lactase is an enzyme that breaks down lactose. So you can see on this first picture on the left, it's breaking down the lactose into glucose and galactose. And so it gets broken down in the intestine, and then of course we absorb the glucose and galactose, and it's all good. Some people who are lactose intolerant, you see what happens is in most mammals, what happens is lactase is produced by the infant. And at some point, by the time they're weaned, the infant is not producing lactase anymore. And a lot of animals adjust and don't eat any dairy products in their diet. Humans, on the other hand, at least if you're from some parts of the world, have developed a way to consume milk products much later in life. And, for the most part, that's a good thing. There's a lot of nutrients in milk. And so, calcium and protein and those kind of things. And so many of us can digest milk all our life. For some people, they become lactose intolerant later in life, in their adulthood and whatnot. So what's happening in lactose intolerant people is they still have lactose in the milk. But the problem is the bacteria basically take it and start fermenting it and produce all sorts of gases and acids. And this leads to, intestinal gas and sometimes pain and those kind of things. And, it is what it is. Some people can't have milk, and so they have to find calcium and protein from other sources. And, not really a big deal unless you're really into dairy. I'm really into dairy. I would have a hard time, I think, if I had to go lactose intolerant, but there are lots of products out there. I want to show you this map here, right, in terms of, geographically, where people are lactose intolerant. So generally, if your family of origin is from Europe or lots of parts of Asia, you can digest milk. If your family of origin is from warmer parts in Asia or Africa or South America, you have a higher chance of being lactose intolerant. So in Canada, for example, I looked it up, and apparently about 16 to 25% of Canadians are lactose intolerant. So that means about 80% of us can consume dairy products just fine. So as a lot of people think that they are lactose intolerant, but they can still eat dairy products. It kind of just depends on how much you're eating. So if you take a look at this, if you're drinking milk directly, there are a lot of people that are lactose intolerant that can tolerate different types of cheeses, but they can't tolerate drinking milk. And like I said, it's kind of a spectrum. It's not like you are lactose intolerant or you are not. It's a bit of a spectrum. Most people can tolerate small amounts of lactose in their food. If you are somebody who is lactose intolerant, there are foods for you. You can eat soy-based ice cream, and there's all sorts of products that don't have dairy in them at all. But there's all sorts of products out there nowadays that are using lactose-free milks. And what they do is they actually use the enzyme lactase. You can extract that and put it in. They can put it in the food when they're preparing it, and the food becomes lactose-free because it basically it pre-digests the lactose for you and becomes glucose and galactose in the food. Some people who also have these lactase tablets, so they're going to eat some ice cream. They eat one of these tablets. It has the enzyme in there, and then they eat their ice cream. So there are options out there. So like I said, one of the big challenges of people who cannot have dairy products is getting enough calcium in the diet. And so this cannot be stressed enough. Calcium is a really important nutrient to have. And so I thought it'd be worth it to just throw down a slide here of some options for getting calcium in your diet if you're not able to have dairy. And if you're already somebody who doesn't have dairy, you probably know a little bit about this. The thing about calcium in dairy is it's, for whatever reason, it's absorbed by the body better than most of these other products. So you can see tofu, fortified orange juice, sesame seeds, broccoli. Those are the ones that I usually think off the top of my head. There's fortified soy milk as well. Another one that is a good source of calcium is eating sardines with the bones, because bones, of course, are made out of calcium minerals. So anyway, there's some suggestions for some non-dairy sources of calcium. So this brings us to the end of part 1. I hope it wasn't too long and that you were able to follow. As with everything, please do ask me any questions if you have any. Thank you, and tune in to part 2.